Hoping you found this exercise 2-10 sheet. You can tell it's something I borrowed from the internet. Some textbook, it was out of chapter 2. And they are using a fairly common convention of Greek letters for degrees and Roman letters for radians. Not all textbooks use that. Some use Greek letters for everybody, some use Roman letters for everybody. This one, if they want theta, they want degrees. If they're asking for x, they want it in radians. We're going to skip the first section because the principal value is basically the one straight out of the calculator, and we already know how to do that. So we're going to move on down. The directions are a little messy here. For this section, they want us to find the theta to 2 decimal places or find x to 2 decimal places. So they want us basically to round off to the nearest hundredth, and they want us to find 2 positive values of theta or x. In other words, they want us to find theta between 0 and 360. They want us to find x between 0 and it should be 2 pi radians, but since they said that we're rounding off to 2 decimal places, we can round 2 pi off to 6.28. I didn't have enough room to work them out on the other sheet. Also, I wanted to bring back the 3 steps. So the first step says get the first angle straight out of the calculator. We're going to be in degree mode, so we're going to do inverse cosine of 0.36. And the calculator, I believe, tells us that the first angle in that case is 68.90. They said 2 decimal places, so we fill in 2 decimal places. Now to get the second angle for inverse cosine, if we're in degrees, we take 360 minus whatever the first angle was. So our second angle is going to be 360 minus 68.90. Tells us our second angle is going to be 291 and 10 hundredths degrees. So these are our 2 answers. We could check it out. Calculator told us the first angle was about here, 68.90 degrees. And our second angle has to have the same cosine value. Has to be the same x value going across. Which would mean that would make it coming out about here. It's going to have the same cosine value. So that would bring it all the way around to here. And we could check with reference angles. This would be 291 and 10 hundredths degrees. The second one they asked us to try was an inverse sine, still in degrees. So just put it in the calculator. Calculator says 16.26 degrees. And to get the second angle for inverse sine, we subtract if it's in degrees from 180. Which tells us that our second angle is 163 and 74 hundredths degrees. And we're saying that those are our 2 answers. We can check. 16.26 degrees is not really big. But there should be another angle on the circle with the same sine value. And the sines are the y's, the distance above the origin or below. Well, there is another one that is about that same height right over here. So we're saying we're going to go from here all the way around to there. And if we use reference angles, we would find that this is indeed a 163 and 74/100 degree angle. Third one is also inverse sine, but it's inverse sine of a negative value. We'll still use the calculator to get the first answer. And the calculator tells us that the angle with this sine value is negative 38 and 32/100 degrees. Our final answer cannot have a negative. But we're not finished with it yet. This is not our final answer. We want to use this angle. We're going to use it to get the second angle by subtracting from 180 degrees. Because this is inverse sine. Now that's going to be the same as 180 plus 38.32 degrees, as I'm sure you know. And that's going to come out that the second angle will have to equal, excuse me, 218 and 32/100 degrees. So this would be one of our answers. But this angle's not ready for it yet. This is the correct answer. That does have a sine value of this. But all our answers have to be between 0 and 360. This one's not. We have to have a positive angle. So we're going to take this and find a positive coterminal angle by taking negative 38.32 and adding on 360. This is not a brand new angle. This is just another way to name this one. We're not getting a third angle in the circle. That negative 38.32 degrees is the same as, going to end up in the exact same place as 321 and 68/100 degrees. So that would be our other angle. Actually, it's our first angle, just in positive form. 18 and 20 say that they're giving us the trig values for some mystery angle x. So they're telling us the answer is going to have to be in radians for both of these. And the first one's inverse cosine. So we make sure that our calculator is in radian mode. If it's not in radian mode, we'll put it in radian mode. Oh, this one's already in radian mode. That's good. And now I'll ask it to find the inverse cosine of 0.73. And it says, to the nearest hundredth, it says it's 0.75. So our first angle in radians is 0.75. Now radians don't usually get labeled. I'm going to label it just so it doesn't look like a cosine or sine value. And then to get our second angle, now in degrees, for inverse cosine, we would be subtracting from 360. But in radians, we subtract from 2 pi, which is the same as 360 degrees. Since we're rounding everything off to 2 decimal places, I'm going to go ahead and round 2 pi off to 2 decimal places. Now you can just retype that in the calculator because it's so short. But you can look around and see if you find a key that has the letters ANS. On this particular calculator model, it's the second function on the negative key. On some calculators, it's the second function on the equals key. So another way to do this, especially if it's a much longer decimal than 2 places, is you type in, for this case, 6.28 minus, and ask it for second answer. And it's saying, I'm going to take 6.28 minus whatever the last answer is. And it tells us that that's to the nearest hundredth, that would be 5.53. Which once again is in radians. We could check that out on the circle. Remember from earlier lessons, in radians this is 0 or approximately 2 pi. Over here this is pi or approximately 3.14 radians. At the top, half a pi is about 1.57 radians. And down at the bottom, 1.5 pi's, that's about 4.71 radians. So the first one was 0.75, which would put us close to the middle here. And there's another angle in the circle with that same cosine value. Cosines being the x's. So we want another angle that's got that same cosine value. Maybe right about here. So we'd be coming all the way around to here. We said the answer was about 5.53. Well, this is 4.7 and this is 6.3. This could very well be 5.53 radians. So the method's working, whether it's in degrees or radians. To finish off the category, I want us to find the radian measure of an angle with a sine value of 0.52. So we just ask the calculator. Calculator tells us, I believe, that the first angle is 0.55 radians. And then for the second angle, because it's inverse sine, normally we'd be taking 180 if we were in degrees, but we're in radians. So 180 degrees is the same as pi. But because we're rounding to 2 decimal places, we can round pi off to 3.14. And that would tell us that our second angle is about 2.59 radians. And those would be our two answers, because they are both positive. So it's a lot of steps, but it's not too bad.